NextJS is taking the web development world by storm. About 4 or 5 years ago, pretty much nobody has heard about it, and now it's actually the third most used web development framework according to Stack Overflow. And this is quite interesting because such a fast-growing framework does come with a couple of downsides. One of them is that about a month ago there has actually been a very big update which completely changed the framework. So people who know Next.js already have to learn completely new things about it. That's what this crash course is all about. We're going to check out the new Next.js with the app router. And this is what the future of Next.js will look like. I think it's a really good future. It does have a couple of minor developer experience issues, but most of it's pretty good. Well, my cat is jumping around, so just ignore her. So, Next.js, what is it? It is basically a framework for React. So I'm assuming that if you watch this Next.js crash course, you know about React, at least a little bit. You don't have to become a pro at React, just know the absolute basics. But it is a framework for React. Now, what does that mean? So React is basically an HTML rendering library. Some people call it a front-end framework. It really isn't. All that React does is it takes data in your JavaScript and render it to HTML. And when that data changes, it reacts by updating the HTML as well. That is really all that React will do for you. Now, if you want to create a full-stack web application with a backend and a database and whatever, React is kind of falling short because you need to introduce different systems that take care of the server-side things. And then again, because React is a client-side library, browser front-end, it will render all of the HTML in the browser. It uses JavaScript to just add HTML to the page. And this has lots of downsides. For example, with search engines, Google will not actually be able to see what's on your page until React is done rendering. And Google and other search engines may not understand completely that they have to wait for React to be done creating HTML. They want to read the HTML in order to see what's on your page. But if they don't see any HTML, this will be very bad for your search engine optimization. There's a couple of other usability and just general performance issues with just pure React. Next comes in to help with that. It's a full stack framework. And it actually takes the new React feature of server components. So we can actually now execute React components to generate HTML server-side. And it uses that feature to create a full stack framework using React. And that's what Next is. So whenever a user wants to navigate to a certain page, Next.js will decide, depending on how we've configured our components, to maybe render the component on the server, generating the HTML on the server, and then sending the HTML already done to the client. If the HTML doesn't change very often, it might actually cache the HTML so that the next user who requests this data or this page, we don't have to wait for the React component to render again. It's already there, it's cached, it's saved. But we can also configure it to always maybe re-render it. Or we can say, well, this is actually a client-side component. Just render this in the client. And there's pros and cons with all of these methods, but Next makes a complete hybrid application in ways that I don't think any other framework can. We can say, oh, this component needs to be rendered client-side, this needs to be rendered server-side, this needs to be generated statically. So when we build the app, then we just generate the HTML and then it's just a static HTML file. We can do something called incremental static regeneration, whereas where we maybe have data that changes maybe only once a day, and then we just say, oh, well, at most once a day regenerate this HTML. There's loads of cool things to optimize the experience for the user. So what we're going to do in this video, which is a crash course for the new Next.js version, we're going to check out the core of Next. Next is quite complex, it can be quite complex, but the basics are not that difficult to understand. And that's what we're going to check out in this video. So what I've done is I've opened up my terminal and I've navigated to a folder where in that folder I would like to create my new Next project. Now we do need to have Node.js and npm installed, so we can run npx to execute an online npm package, and I want to run create-next-app. So this will download the create next app package and run it. And this create next app package is like a template for a working Next app. We can kind of configure a few things, but it will just create a folder with everything installed for a new Next application. Then we have to give it a name, so I'm going to call this the NextJS underscore crash underscore course. We can't use space bars or uppercase letters, so we'll write it like this. Now when we do that, it might ask you to first install create next step. You just say yes, I already have it. And then we can configure a few things. So we can enable TypeScript. I'm going to say yes. ESLint. I'm going to say yes. Tailwind. So maybe you like Tailwind, maybe not. You can choose yes or no. I'm going to say yes. Well, I'll not be doing too much Tailwind nor TypeScript really in this crash course. There will be a little bit, but you don't really have to know them. There will be a little bit of TypeScript. So if you haven't used TypeScript before, it's actually not that bad to keep watching, because I will be explaining what I'm doing, and you'll probably learn a bit about TypeScript as well. So then would you like to use the source directory? So instead of, or the opposite would be to just dump all of your source code in the root project folder. I'm going to say yes, I would like a source directory. Would you like to use the app directory or the app router? So yes, this is the new app router. You can still use the old pages router, but I'm going to say yes. Would you like to customize the default import alias? So this is actually going to allow us to use the @ symbol when we're importing modules. So import something from, and then we can just say @ / whatever. This will always point to the source directory instead of us having to do .. .. to maybe go back to the parent folder. So I'm going to say no, we don't want to customize that. I think that's just fine how it is. Now it's going to install everything. And once that's done, we will have a completely working Next application. So just give that a second. It's installing React, React DOM, Next, basically everything that we need. This is really the core of Next. All of these others are just the extras we added, like TypeScript, Tailwind, ESLint, stuff like that. Let's open this project in VS Code. And let's take a look at what we get here. So this is our project structure. We have all of our config and setting files and whatever in the root. And that's why I like this source directory, because otherwise my source code will be scattered among all of this. And in the source directory, we have the app directory. And that is the core of the Next router system, which I'm going to explain in the first part of this crash course. We also have a public folder. So if you're unfamiliar with the public folder and how module bundlers work, anything that you put in the public folder will just be a public file. The browser can just request it via the file path as a URL. So this Next SVG file is at the root of the public folder. That means that we can actually request whatever your domain name is /next.svg. It's just accessible. So you don't want to put private things in here, just things that you need the browser to have access to, like an image file or something like that. The source directory is where a module bundler, and I think Next uses Webpack by default, is going to bundle everything together. So in all of these JavaScript files, or in this case we're using TSX, TypeScript, XML. This here of course is JavaScript XML, where we're using TypeScript to allow us to write HTML in our React components. So these TSX files, they're importing things from other things. And the module bundler is going to look in the source folder for everything that needs to be bundled together so that the imported stuff are together in the actual final build of the app. So in other words, we just put all of our source code in this source folder. I'm going to explain exactly what's happening in the app directory in a moment. But first, a little bit about these other files here. So in the package.json, it's one of the simplest ones there are. There's just a list of all of the NPM dependencies, and then there's a couple of scripts. So we have the dev script, which will build a development environment build for the source code, and then it will also host a live server, which will automatically refresh the page when we make changes to the code. We have the build command, which will make a production environment build, and we can start that production build with the start command, and then we can optionally just manually lint our code if we want to. So what I'm going to do in order to explain how the Next app router works is start from scratch. This is actually an example app with some page already here. We can start working from this and just continue with what we have here. That's what you would probably normally do when you start a new Next app. But I think in order to learn everything from scratch, let's also start from scratch. So I'm going to completely empty the source folder. It's now an empty folder. I'm going to empty the public folder. And the only other thing that this example app introduces is in the Tailwind config, they have this theme that they extended, which I'm just going to remove the background image extended theme to. But all of the other configuration here is already done. You can see it's going to look for your source and components or app. What I actually like to do is just delete these 2 lines and just look for anything in the source folder, any subfolders, any files that have the extension JSTS, JSX, TSX, or MDX. So we're not going to have to worry about whether things are in the app folder or in a components folder or other folders, because I might introduce some other folders with React components as well. And the TypeScript config is already set up as well. This is where that alias will live. So it basically says, hey, anything that you have in your import path that starts with @ map it to from the root of the directory or of the project source /, right? So it's just going to be mapping that to give us a little shortcut. So now we have the most empty project possible that we can get with create next app. Let's start from scratch. So the very first thing that we need in the source directory is a folder called app. We are using this new app router. You can actually still use the old pages router. They will work side by side, at least for now, so that it will make it easier to migrate from one to the other. But we are just going to focus on the app directory. Now the purpose of this app directory is to allow us to define a folder and file structure which will map to a URL structure. So, for example, if I were to create an about folder, any React components that I put in there, it's not completely true, but you'll see that happening in a moment. If I create a page component in here, this will map to the URL /about. So when the user visits the page /about in the URL, Next will know which component to render. It's going to look for a page component in this about folder. If I create another subfolder in there like test, then this will map to the URL /about/test. And that is how we can do our routing. It's file-based routing. Now, in order to make this work, we need 2 things which are absolutely required in order to make the next app work. So I'm going to create a file in the app directory. I'm going to call that layout.tsx. This is a required file. The app will not work without a layout file at the root of the app. This is known as the root layout. And I'll explain a bit more about what layouts are in a moment. But what we need to do in this layout is set up the root of our element structure. This is like the root component, which will render all of the other components. It's like the core of our app. And when we're thinking about it in HTML terms, this is kind of like setting up your HTML tag and the body that wrap around the whole element structure. So the whole idea of this layout, the root layout at the root of the app, is that we export a default export, and it needs to be a function React component, a React function component. So we can name this whatever we want, but I'm going to just call this root layout. And then this needs to return the HTML structure that we want to render on any page. So this will be the HTML element. And we also need a body. Now, normally you would also have a head element, but the head elements will actually be generated by Next automatically. And we'll come back to that later. And of course in the body I could add things like, whatever content I want. But really the purpose of a layout is to take in children components that are passed into the layout by Next, and then we can decide where in this structure we want to put those children components. Now, what are these children components? Well, like I mentioned, depending on the file structure and the folder structure, and depending on which URL the user visits, Next is going to look for a matching file structure and decide which page component to render. And that page component will then be passed into the root layout as a property, so we need to ask for props. And then we can decide where to render the children props object or component really. So Next is going to choose one of our page components, which we haven't created right now, but we'll see that in a moment. And it's going to pass that via props into this root layout. And then we can decide, well, actually I want my pages to be in the body. So if I do props.children, which is the name of that prop that Next gives it, this will be the place where all of my pages will live. So my page components will not need their own HTML in their body. They will always be added by the layout. But then Next will just swap the component that we use to render the pages, depending on which URL we're visiting. So this will be the normal JavaScript way to write this. But you can see we have a little warning here that TypeScript gives us. Because TypeScript wants to know, well, you asked for this props thing, but what is it? Is it a number? What is it? So we want to create a type definition. So what I usually do is actually create either a type or in my case, I'm going to use an interface. And really, type and interface are, for most intents and purposes, the same. They allow us to create a type definition of something. And in JavaScript, you would usually use it for making a structure of an object. So props, of course, is an object. So I'm going to call this interface the children props. And I'm going to say it's an object that contains a children property. Right? Props is an object that contains a children property. And then we have to tell TypeScript what children is. What is this children? Well, of course, you won't know it right now, but if you read documentation about TypeScript and Next and React, you know that children will be of the type React. And so the React package, we import that, and it will contain an actual type definition called React node. And a React node can be anything. It basically is a type definition for anything that React can accept as something that we can add in JSX, something that we can render inside of JSX. So it can be a string, a number boolean, a React element, a JSX element, right? So it can be a component, an array of components, all kinds of stuff. So now we can say that props is actually of the type children props. So now we have complete IntelliSense, like if I do props dot, we see, oh, it's children, and children is of the type React node. So it's always a good idea to define the types of anything that you're working with. So what we have here is our root layout. This is the component that will always be added to the page, regardless of the URL. Then, depending on the URL, Next is going to choose one of the page components, which we'll make in a moment, pass it into the children property of the props object, and put it into, in this case, my HTML structure. By the way, we can actually simplify this even further by destructuring the props right into the separate children. Out of context, really strange, and then we can just say children here. So this would be the normal way that I would write my props. I define an interface somewhere, and then I can destructure that property. So, if we were to render this app, nothing would happen. Because Next has no clue what page to add to the root layout. We need pages. Now again, depending on the folder structure, that will map to an URL. So if I create a file at the root of the app, that will match the root URL. So yourwebsite.com/nothing. That's the root URL. Now, if I want to make Next understand that we have a page component, something that we want to add to the page, it needs to be called page.tsx. Or JSX if you're using JavaScript. So we have layouts and pages. Those are named files, and the name means something to Next. Now again, the page just needs to export, as the default export, a function component. And we can call this whatever we want. I'm going to call this home page. And now in this home page, we simply need to return whatever content we want to have for the home page. So we'll have the main element, for example, and let's have an h1, welcome. And then we might have some links or whatever later. For now, we'll just leave this h1 here. So now what's going to happen, and we'll see this happening when I start the server in a moment, when we navigate to the root URL. So the server will run, for example, on localhost port 3000. If I go to localhost 3000 / Next is going to look for the path / from the app router, and it's going to look for a page.tsx file. And it's going to take this component that's exported from that file, add it via the children prop into the root layout, and then we can insert it into the HTML body. Let's try it out. We can run that npm run dev script. And this is going to start it on localhost port 3000. So let's open that. And this is a development server, so you may sometimes see it loading for a moment. It's doing all kinds of development stuff. You won't see that if you use the build command to create a production build. But here we have that h1 welcome. And it's added, of course, to the HTML structure. There's lots of other stuff, scripts, and there's actually a head element with some basic things here, which Next actually applies by default. Alright, so this is just default stuff that Next adds. And we can configure what's in the head element ourselves later. But you can see our body contains the main element and the h1. So that is what Next has done. It has taken our basic HTML structure from the layout, apply the scripts and the other things that Next needs, and then it takes the page, depending on the URL, right? We're at the root URL, so we'll take the root page in the root of the app, and we'll add that HTML to the body. That's what is happening here. Now, if I want to create a different page, I can simply create a folder. So let's say we create an about folder, and in there I can also create a page. And we again export, as the default export, a function, and we'll call this about page. You can name it whatever you want. but the file needs to be named page. So Next is now going to look, if I navigate to /about, it's going to look for a page file in app/about. It maps to that URL. And now of course I can return another main element for good semantics, and we'll have maybe an h1 that says about us. So if I navigate to /about, there we have about us. Alright, so Next will now swap the contents of the component, the page component. The layout will stay there, it's the same for everything, but the pages are swapped depending on the URL that we are visiting. So that's the purpose of these layouts and these pages. So the folder structure maps to URLs. When the user visits that URL, Next is trying to find a page component from a page file in that URL folder structure, and then it's going to apply it to the root layout. Now these pages look absolutely horrible, so let's enable Tailwind. Now we already have Tailwind installed, and if you don't use Tailwind, you can just use CSS. But I'm using Tailwind, so of course we need to include the generated Tailwind classes into a CSS file that we add to the page. So I'm going to just make a new folder next to the app folder called style, and in there I'm going to create let's call it a global.css. And if you're familiar with Tailwind, you know that we need to use the Tailwind option here to import the base, the components, and the utilities from Tailwind. These are all of the generated classes that Tailwind will generate when it is reading my classes in my HTML or in any of the files that we have defined here. So basically anything in the source folder. And it's basically cloning all of those files and adding them, or all of those classes and adding them to this global file. So all we now have to do is make sure that this global file is always added to the page. Now because the root layout file represents all pages, we can actually just import, I'm going to do add to always go to the source folder, style/global.css. And this will now apply Tailwind. There we go. So we have our Tailwind styling done. And now for example, in our homepage, I might give this a class name of text for Excel to make the text a bit larger. We might do the same on the about page, something like that. So now we have Tailwind working. So the next thing I would like to point out is route groups and using other layouts. So the app that I would like to build in this crash course is like a very simplified fake social media app where we can make posts and comments. So what I'm going to do here is I kind of want to create two sections of our app. We want to kind of create our homepage with some, introduction, and I want to have our about page with an explanation of what this is all about. But then I want to have a different section where we actually have the social media app. So where we have all of our posts. And why am I talking about sections? Well, maybe they look completely different. Maybe the post section has completely different layout and the home section has a different layout. So for example, what I'm going to do here is in the app directory, I'm going to make a new folder. And in parentheses, I'm going to add general. And I'm going to take the about folder, drag it into general. And I'm going to take the page file. And we will be... Oh, this is something that sometimes happens. So whenever VS Code thinks that you have changed an import in one of the generated files in the .next folder, don't do that. Don't save that. It's really strange why it does that. I hope it will be fixed at some point. So we take our about folder to the general folder and that home page to the general folder. And again, no idea why it wants to do something in the .next folder. That's the generated app. We don't want that. So now we have our root layout, but then we have this parentheses general folder containing our homepage and our about folder. Now, as I've explained, the folder structure maps to URLs. But as you can see, the homepage should now be at the path /parentheses general parentheses, right? But it's not. So if I go to /about, it still works. So parentheses create a route group. It's kind of just like a folder containing other files or folders, but it's excluded from the routing. So this general folder will still, or these files and folders within the general folder will still map to app/about or /the homepage. Now the reason why I'm doing this is you can actually apply layouts in these in any subfolder or any route group folder. So I can make another layout. Now let me explain in a moment why I'm making another layout in this subfolder. We have a root layout and now I'm making another layout. And I think it will become clear what I'm doing here as I'm building this. So I'm going to export another function. I'm going to call this the general layout. And all that I'm going to do is return a div. And of course we need to have the children. And now, well, here we have a small problem. We need to use this same interface. So I think it's a good idea to cut out this interface, create a new folder in the source for my types, and just create a children props.ts file, and then we'll export that interface. So in the actual root layout, I'm going to put my cursor behind children props, control spacebar to open IntelliSense, and then enter to complete the auto import. And now we can use that same children props, import that to indicate that this layout will also receive children. And I'm going to put these children into the div. But now we can style this div. And I'm going to say that our general layout, any page in the general layout will need a maximum width of, let's say like, I don't know, 600 pixels or something like that. And I will say margin X, so left and right, auto. So do we center that? All right, so let's try this out. And as you can see, we now have our welcome centered into the page. And the same will happen to /about. So this layout is now stacked upon the root layout. So let's just go step by step through it. When Next decides to, let's say, render the about page, right? We're on the path /about. So it will first apply the root layout, which takes any child component that Next decides need to render, and it puts it into the HTML and the body. That's it. Then we go a step deeper towards the page component of the /about route. We go into the general subfolder, the general route group, and this has its own layout. So this component will now be added as a child property to the root layout. And this layout will now add a div with that centered page basically to the root layout. So in the body we'll have this div with the centering classes of Tailwind. And then we're going to take further children. So Next is going to go a step deeper into where the page lives, which is the /about folder. And then we encounter the page file. And this is the thing that will be added to that general layout children. So we can have multiple layouts that stack. So this is why the about and the home page are now centered, which we may want. For example, if I go to the home page, I might have a bit of text here like lol ipsum, which is now nicely centered into the page. And you know what, we'll do the same on the about page just so we can see something there. So now, there's the about page. Let's talk about why I have added that route group of general. So the cool thing about these is I can now create another route group. And I'm going to call this posts. And in posts, I'm going to make another layout .tsx, export default function, and we'll call this posts layout. And this is the section where we actually have the social media section of our app. And we're going to create a different layout, different UI, different styling for that whole section by wrapping all of the child pages into this layout instead of the layout for the general pages. So again, we will get the children props. And then we might have another div here and we'll put the children in there. Always sounds really strange out of context. Let's not talk about children anymore. And here I might maybe, I don't know, we'll create a background that is, we'll do some cool styling here. We'll create a, let's do like, let's try to find a cool color. Something like maybe the dark sky or this dark blue color. Sure, that's fine. And then I'll have another div around the children. And we'll have a class name with margin of 4, background of white, and we'll do rounded large, or maybe even XL. Is that a thing? Yep. And padding of 4. So now we have a background and then this kind of white rounded section in between it. I'm just thinking of some interesting style to add here. And that will contain the children. Now, of the posts, we need to create a folder structure now for a URL that we can map to some of the post pages, like the actual post route. So again, in the routing, this post route group is ignored. So app/posts is now a route. But because we have a layout in that route group, we now no longer apply this centering layout to that we have in the general section, but now we have our own post layout to this post page, for example. And let's just export default function posts page, and we return a main element with an h1 that says all posts. And again, I'll use text for Excel. So now let's navigate to /posts, have it render, hopefully. So apparently it doesn't work yet. Let's see why. All right, so I did find a mistake here. So I forgot to add the return statement in the post layouts, right? So I just added the return and wrapped the divs in there. Now my beautiful design doesn't work, of course. So what we need is a min height of the screen. So that's going to apply that blue color to everything. And then I think we need to do box border around this. I kind of wanted to not have the margin around this. Actually, what we can do is we can just apply padding on the inside of this div and then not deal with margin. There we go. So this is now my design for the post page. We have this kind of blue background, and then we have the kind of the content in this white box around it. Doesn't matter what you think about the styling. This is just an example. But the main thing I want to point out here is that we now have two route groups, each having their own layout. So our general has its own layout. So any page that's in that general subfolder, a general route grouping folder, like the home page, will have this layout. And the about page will have this layout. But our post page will have this layout. So completely different style. So think of it like having a dashboard and your homepage section or something like that. Or maybe a login section that has different layout. So it's really cool that we can group those together. So next is just going to stack the layouts, and then at the end it will have a page that it will render. Right, so now that we know about the basics of routing and layouts and pages, let's create this kind of fake little social media app. And what I'm going to use for that, I'm not going to set up a whole database. Instead, I'll use something called JSON server, which is an NPM package. And this is like a local running server serving a JSON file's content, kind of like a JSON database like MongoDB almost. And that server that it's going to run, we can actually request, get and post requests to manipulate or get stuff out of that JSON file. So when we install this, the way we run it, is we create a db.json file at the root of our project, and then we run this command to watch that db.json. And then if I go to a certain request, we get like post with the ID of 1 or something like that. So it's pretty cool. So I'm just going to use this to mock up a little database without actually having to use a database. So let's go and install this. So let's open a new terminal and npm install JSON server. And I'm just going to go and create a db folder, and we'll create a db.json. And in here, I'm going to create an object with posts, and post is going to be an array with our posts, and each post will have an ID. So I'm basically seeding the database here. I'll just create 1 or 2 posts. So we'll have an ID, they'll have a title, and we'll say like first post, and they will have a body. That's going to be like, I don't know, lorem ipsum. Sure, this is our first post. Let's just create a second one. So ID 2, we'll do second post, and we'll say other content. Okay, so we now have our like little database here. It's an object that is a posts array, and we have objects in there for the posts. So now what we should be able to do is run this watch command, And then we should be able to request things like /post/1. So let's run this command. And we don't want to point it to db.json, but db/db.json. Oh, command not found. Oh, they wanted me to install it globally. Well, we don't want that. So let's just npx to execute JSON server. Oh, so yeah, of course, localhost 3000 is already in use. So we probably can, maybe it says it somewhere. I'm just quickly going to look. There we go, port. So I'm just going to use port 3001. And you know what I'm going to do is I'm actually going to run this. So it's running. I'm just going to copy this command here and put it into a little script so I don't have to type it again. So we'll call this db and we'll just put this in there. So let's just now npm run db. And now we get that little JSON server running on localhost port 3001. And as you can see, we have a link to /post. And if I navigate there, this is what we get, right? So this is my request to localhost port 3001 /posts. And we get our array with our posts. So how cool is that? And we can also actually make an HTTP method post request to add things to that JSON file. So we can manipulate the JSON file. So what I would now like to do is implement that behavior in our project. So let's go back in here and let's go back to our posts page. And in here, I basically want to fetch all of the posts. Now, if you are using React, you probably know that you have to use an use effect, which will trigger an asynchronous function that will fetch the data. And then once the data is there, we have to put it in state so that the component can update when the state receives its data. If you're familiar with Next in the previous pages router, you may be familiar with the export async function get server side props. So with normal React, of course, which runs on the browser, we have to do our fetching client side in the component itself. With the previous pages router, you would be able to get this separate function to get data asynchronously. When this page component has to be rendered on the server, we first run this function that will be awaited. We then would fetch our data in here, and then we could pass our data as a prop to the actual component. But now with Next in the app router, we can actually make the whole page component an asynchronous function and just do the fetching in here. So this is like the best option at all. We don't need anything separate. It's just, hey, we render this page. Well, first we get our posts response. So first await fetch. And I'm just going to add whatever that request was. This one, http://localhost port 3001 /posts. Right, we're just going to request this data from our separate JSON server. And then we're going to parse the posts. So we await the post response.json. And only then, after we are done awaiting the getting of the posts, will we render the content. So now we have our h1, and then below it, actually let's put it into a UL. Now I basically want to render all of our posts. So before I'm going to do that, however, I think it might be a good idea to apply some TypeScript type definition, because right now TypeScript has no idea what this is. Let's go and create a new type, and we'll create a post type.ts, and we'll create an interface which will export. Sorry if you can hear some saw noises. My neighbors are sawing some wood or drilling or something. I don't know. Hopefully it's not that horrible. And we'll create a post type. And we can say that our post will have an ID, which is a number. And our post will have a title, which is a string. And it has a body, which is also a string. So now we can say that this post's data that we're getting from the parsed response, we can treat that as an array of post type. So there will be an array with posts. And now we can actually get nice IntelliSense for example, posts dot, and we can see things we can do with an array like map. And this is of course a normal React way to map an array of data to multiple elements. We use the map function to basically apply a for each loop over each post. and then we have to return. I'm going to use a list item. Right, so and because TypeScript knows that this posts is an array of post type, that means that every individual post we're looping over is of a single post type. And that means that in here we can, for example, make an h2 with post dot, and we have all of the data in there, title, and I think I might actually make this whole thing a link. Now I'm using an A tag here, and I'll come back to that in a moment, because this is not the proper way to make links in Next. But let's just do a href here, and I'm going to create a href out of a template string, and I'm going to say it will be /posts. So that will map to the post page, but we don't want to go to the post page. I want to go to a sub page for just a single post, and I'm going to just apply the post.id. So this will map to post / whatever the ID, like /1/2. Now we need to create those post pages later, but that's what I'm going to do here for now. So we have our lists, list items, which are a link, which have a header with the post title. Really, we could just make a span, I guess. Headers don't really make too much sense. They're not heading anything. So we're looping over all of the posts, creating list items, which need a key, by the way. So everything in React as a list needs a key, a unique value. We can just use post ID because they should be unique. Cool. Let's go back to our post page, and look at that, we got our posts. So that little JSON server is just any server that serves data. You can use your own server, your own database. Later on I'm going to show you how we can set up our own API endpoints, like /posts from our API to maybe serve some JSON data right from the Next app. So if you have like a database and an ORM, or whatever you're using to communicate with the database, you can just create an API get endpoint or post endpoint right in Next. But for now, we're just relying on this JSON server package to just serve some data. And as you can see, we get our titles here of those posts. If I click on them, we'll be navigating to a page which doesn't exist yet, but it will be /1. Pretty cool, right? So in Next.js with the app router, if you want to fetch data, we can do it right into the page component. Right in the page component. We just have to make it an async function, and then we await the stuff that we need to do. And only then will it go to the return statement, because we have awaited everything. So no more back and forth with an use effect and then waiting until something's wrong and adding it to state so the component will re-render. That still has to be done when you're using client-side components. And we haven't talked about client-side components at all. I deliberately have left it out a little bit, not to confuse you, but that will be coming up soon. But this is how we will fetch our data here. Okay, at least server side. So let's set up the page for the individual posts so that we can click on the links and actually navigate there. So I want the route to be /post/ and then a number. Now, this will map to app, posts, and then like number 1 or number 2. But obviously people will be adding more posts, and I am not going to sit here the whole day adding these folders and page components for whatever ID there might be possible. So what we can do is we can rely on what we call dynamic routes. And dynamic routes are made with square brackets. And inside of the square brackets, we give a name to the value that we can get at this position in the URL. So this will be /post/ and then some kind of value. And this, of course, will be our post ID. So I'm going to name this dynamic route post ID. And what this dynamic route will do is it will capture the URL /post/ anything. And whatever the value is at that / after the post, we will be able to use that value in the actual page. Let's make a page.tsx. Export default function. And we'll call this the post page, not plural posts, but singular post. And here we're going to return a main element for that page. And here we're kind of going to have maybe an h1 with the like post.title. And we might have like a div with post.body. But of course, we don't have those. We don't have this data yet. We have to fetch it, right? So now what we would have to do is if I, if I, for example, navigate to the JSON server, port 3001, we have posts. But if I do /1, it will actually try to find just the one with that ID of 1. So the JSON server can already serve this data. But now we want to, on our next server, serve a page for /1. Right, so this is not going to work just yet. Of course, because we don't have post defined yet. So really what we need to do is make this another asynchronous function so we can make that JSON server request. So post response is await fetch. And we kind of do this, but I don't want to hard code in /1. No, what we need to grab whatever we have at the URL. If there are 100 posts, I want to be able to capture the value 100 from the URL. Now Next will actually, when you're using a dynamic route, it will actually give you the value at the position of the dynamic URL segment. So /post/ and then there's the dynamic segment. It will give you the value of what's in the URL via props. So let's go and make another interface for defining the type of that props. And I'm going to call this the parems props. And this is going to be an object. And this object is going to hold parems. Actually, I'm not going to call this parems props. I'm going to call this post page props because they're specific for the post page. So Next will create a property called parems. And in that parems, it's going to create a property with the name that we have given to the value of the dynamic route. In my case, it's going to be post ID. And the value of that post ID property is always going to be what is in the position of the URL. And it will always be a string, of course. So the type is now that we're going to get props from React, or from Next really, and it's going to be of the type post page props. So props will be an object which has parems, which will hold all of the URL parems, in this case only the post ID. And we can of course destructure that parems right away. So now I have used backticks for this string. Instead of just hardcoding 1, we can just put in parems.postID. So whatever is in the URL, we're going to get that post ID, and then we're going to fetch just that post ID from our database. And then we just need to get the post and await post res.json. And we can actually set this as a post type again, but not an array this time, it's just a post type. So make sure you put parentheses around the await here. And now suddenly we have our posts when we return. So let's go back. Now of course post 100 doesn't exist, but 1 will. Look at that. We got our first post with the lorem ipsum content. And if I navigate back to our all post page and we go to the second post, we have our second post title and the other content. Right, so we have now fetched that data from a database for the individual post. So this is how we can read dynamic URLs. The cool thing is we have just this one component, but the data that the component uses is dynamic. So depending on the URL, we just get whatever data belongs to that URL post ID segment. So we don't have to make thousands of post components. Really, really cool. So that's how we work with dynamic pages. All right, so this is the main part of the whole routing of Next. There's a couple of other things, but this is like 90% of what you have to know about routing. So we have our folder structure, normal folders mapped to URL segments. Parentheses are just groups. We can just group things in folders. They don't do anything else. And then we have the square brackets for making dynamic routes. And then the URL parameter will be given as a parems prop to your page component. So you can read the value. Now, let me show you a little weird thing here. Let's go back to /posts. And what I'm going to do in my database, let's say I'm changing the title of second post. And we're going to call this NextJS. Save. So if I were to reload this page, obviously we're going to request the /post page from Next. Next is going to look for the post page. It's going to fetch all of the posts, so we should be fetching the new one as well. And then it's going to map over all of them and show that title in a link. Well, watch what happens if I reload. We still see second post. Let me try to reload again. We see second post. I'm going to reload again. What's happening here? So it's very important that we understand a big part about data fetching in Next.js. There are two things that we need to understand about it. One is, where does the data fetching happen? Client side or server side? Now, we haven't done any client side stuff yet. All of this is server side, but we'll learn about it in a moment. The next thing we have to understand is it dynamic fetching or static? All right, so in order to explore a little bit more about what all of this means, I've made a little diagram here which we're going to fill in. So there are six, well, maybe not exactly six, but there are server-side rendering, client-side rendering, and then there are three types of dynamic or static rendering that we have to understand. So let me go over what this means first, server-side and client-side. When we talk about server-side rendering, that means that the execution of the component and the creating of the HTML is happening server-side. So on the server, not on the user's computer, not in the browser, it's happening on the server. The user requests a page, the Next.js server will generate the HTML based on the component, and then the HTML will be sent to the browser. So when we visit a page, this HTML is not created by React in my browser, like you would normally get with React. This is just HTML that the server sends to us, but the server used Next and React on the server to generate it. Now obviously then, client-side is what React would normally do. Client-side rendering means that the JavaScript containing the React component code, this stuff, is sent to the browser. The browser runs the JavaScript, which will then fetch the data from the browser. So that will be literally a fetch request made back to my server for that JSON data, and then it's sent back to the browser, and then the React can render the posts. That is what you would normally expect with React. So things are either happening on the server sends the generated HTML to the browser, or things are happening client-side where the JavaScript renders the HTML in the browser. It's a big difference. Then we have static generation. Static generation means that your component, so let's for example go to our home page, this is a good example. When the server runs this component and it generates the home page HTML, it will save this HTML, like basically create an HTML file, but it will save it. So that the next time a user visits this page, we don't have to run the component again. The HTML is already created. And for this home page, that makes sense because there's nothing in this component that changes depending on user or depending on the request or the time. This content is always the same, unless I literally change something in the code. But we can just say that, well, you know, we'll just generate this HTML once and that's just the HTML that everybody sees for the home page. That's what we call static generation. We generate it once, we save the HTML. This is now static, it doesn't change anymore, and we just serve that. Incremental static generation means that, well, let's say that we have our posts. This is our all posts page, where we're getting all the posts. And let's say that we're not really going to update these posts very often, right? Maybe I'm adding a post every week or so. So the HTML that is the result of this component, so we fetch the post once, we generate the list of all of the posts and the header, but then we still save it. But we're going to keep it only for a week. And if someone makes a new request for the post page after that week timer has expired, we just generate it once again. Because I'm going to say, well, at least once a week I'm going to make a new post. Or we could say every day, or every hour, or every minute, or every millisecond, I don't know. But we can set some kind of timer that invalidates the HTML. And when that timer is expired, we just generate it again. So this is good for dynamic content. So here we have dynamic content. This comes from a database where the database can change. It's dynamic content, but the dynamic content doesn't change very often. So if thousands of users are visiting our social media app every minute, but I am never going to change the post like multiple times each minute, it doesn't make sense to just keep fetching and rendering all of these posts over and over again. So we can just generate it once, save it for a certain time, and only when the timer is expired, generate it again. So now we have, instead of thousands of times generating and fetching this every minute, we just get the saved HTML to the user, which is almost instant. and then just generate it once every minute or every hour or week or whatever you do. So that's incremental static regeneration or generation. And then we have complete dynamic rendering, where we're going to say, well, these posts can change so often that we're just going to say every request we need to regenerate the HTML. We just need to re-render it. So we're going to see whether or not these can be used client-side or server-side. So static generation. Let me see if I can make a little emoji here. So yeah, there we go, checkbox. Yes. So static generation is done server-side. All right, so the server generates the HTML once, for example this homepage, and saves it to the server. And the server will then send the static HTML back. Can we do this client-side? Kinda. Actually, I'm going to say yes with hydration. So what does that mean? So we're going to check out client components later on. Client components are just normal React components, right? Next.js just sends the component code to the browser and it's executed over there. So we can actually say to Next, this needs to be a client component. And I'm going to show you how to do that in a moment. When we do that, when we literally tell Next in this file, this is a client component, what Next will do is it will send the server generated static HTML. Right? So we have static HTML generated beforehand. So any HTML element that is just static, like this paragraph holds static content, that's already generated on the server. And it's saved as a static bit of content. A good example would be this component here. This h1 will never change, unless I literally change the content, but this h1 doesn't change request by request. So this h1 can be statically rendered on the server, but this UL is dynamic. So if we make this component a client component, anything that can be statically generated will be generated on the server and then saved, cached on the server, and that will be sent to the browser. But then once the HTML arrives in the browser, we are also going to send the remaining React code for the component, and then client side we're going to do the dynamic stuff. This is called hydration. So anything that is static will just already be there, so the user will immediately see it. And then we might show a little loader animation until the posts are generated or it is fetched or whatever. And then we can client-side swap that loader with the actual UL with the posts. That could be something we can do. So client-side and server-side static generation are kind of possible client-side with hydration. The same is true for incremental static generation, right? Like I explained, let's say we can tell Next.js, and I'm going to show you how in a moment. We can say, hey, every day update this. Sure, we can do that on the server. Same as with client side, we can do that with hydration. So we can say, well, the static stuff is just generated once, and then we save it for however long that timer is, like a minute. And during the time, we just send the static stuff. Then we hydrate the component with whatever else needs to happen client side. And then whenever the timer is done and someone makes a new request, we generate the static stuff on the server again. And then we hydrate the stuff on the client side again. And then we have dynamic rendering. And dynamic rendering means we're just rendering everything for each request. So whenever there's a request to the server for the post page, we're just going to render this on the server. Or when I tell Next that this component should be client-side, now we're going to do everything client-side. So all of the H1s and all of the static stuff will also be done client-side. When it's dynamic rendering, there will be no caching, no static saving. Alright, so hopefully that gives you at least a somewhat of a vague idea of what all of these rendering methods are. Now we're going to see them in action. So what we have been doing so far is this. All of the rendering we've been doing so far is static generation server-side. So by default, this is the default. Let's move this to the back. Can we not do that? Not sure why I can't put this over the top. Well, it doesn't matter. This is the default. The default way that every component in Next.js will behave. Alright, the default. Server-side static generation. if we take a look at this post page, and we know that the default is server-side static generation, if I request this, even though my database has changed, right? We have NextJS here. I'm going to change this to hello world. Save, reload. You can still, have the very first HTML sent back that we had at the first time before my database changed. Why? Because the default is static generation. The server has rendered the HTML for this component once. It generated a list with links with the titles, and then it saved it. And even though I've changed my database, right, there's different data in it now, we still just get that same HTML back because it's static. Now in this example, we don't want this. So a good option might be incremental static generation or dynamic rendering. And by the way, the reason why static generation is default is for most of your UI, things are never changing anyway, like this homepage UI, it doesn't change anyway. So this component, sure, we can leave it as it is. It's static, server-side, doesn't change. Unless I manually change the component. Then we would have to rebuild the app, which we'll talk about later, to generate the new static HTML. So let's talk about incremental static regeneration. So there's a couple of ways we can adopt this. Let's go to my post page. The easiest way to do this is to export from this file. We have to tell Next how long it has to wait before it needs to regenerate it. So I'm going to export a const variable called revalidate. And it needs to be a number. And I'm going to set it to 60 seconds. Actually, no, for good practice or for just testing, let's do 20 seconds, a bit shorter. So what we have now told Next is that this component needs to be statically generated. We save it and every user will get the same HTML. But if the timer is over, so Next will run this timer in the server. If any user makes another request for this component when the 20 seconds are over, we just regenerate it once again, save it statically, and then we wait for another 20 seconds. So this is in seconds. Let's reload. And now we have hello world. Right, so I just reloaded and regenerated it. Let's try one more. So we'll do NextJS. 20 seconds aren't over yet. So we're getting hello world. And now we're just going to wait for a few more seconds. So 20 seconds shouldn't take too long. And so literally Next is just running a timer. And whenever there's any request, even though the request is made tomorrow, the 20 seconds will be over. It's still not done. And then once the 20 seconds are over, even if it's on a different day or whatever, then it will regenerate the component. There we go. The 20 seconds are over and now we have Next.js. So if you have content that doesn't change that often, but users might request it more than that you're changing it, it might be a good idea to set a revalidation timer. If we want minute, we do 60. And the way that I usually like to set this up is, this is in seconds, right? So we have 60 seconds. If I want that's a minute. If I want an hour, I just multiply it by 60. If I want a day, I just multiply it by 24. If I want a month, I just multiply it by 29. I think 28 is kind of the average month duration. If I want a year, I can also just do times 365. So this will now revalidate it every year. Or maybe we could do every week. So that's 24 times 7. Right, so 60 seconds for a minute, times 60 makes an hour, times 24 makes a day, times 7 is a week. So now we are setting a timer for a week. And only if one user requests this after a week, then we generate the page again. Doesn't matter if the data that we're fetching has changed or not. No, we're just rendering the HTML. And if the data has changed, then the HTML is different. Otherwise, we're just rendering the same HTML. But if we would use completely dynamic rendering, then every request, let's say we have thousands of requests every minute, it would generate HTML. And if the data doesn't change that often, we're just generating the same HTML over and over. So it's a good idea to set a revalidation timer. Now this is a way to set up revalidation for the whole file. So any fetching done in the whole file will be revalidated after, in this case, let's do 10 seconds. But maybe you actually need to fetch multiple things. So you can imagine that we also need to not just fetch posts. In my case, I only have posts, but let's imagine that you also need to fetch comments and maybe user account data for the username of the people who posted or commented and like information. So you might end up with 4 requests. So we can also do revalidation at the fetching level. So let's say that this will be to comments, you know, and we don't have that data, but you can imagine that we might have that. All right, so this will not work, of course, but you can imagine that we do. And let's say that the posts change very rarely. So we can actually add a little option in this fetch function. This is something that Next adds to the fetch function. We can pass in an object, and in that object we can pass in a next property, where we can set that revalidate, I think. Sorry, no, this needs to be an object. And then we can set the revalidate timer only for this request. So we will then, for example, say this will happen 60 times 24. So this will happen only every day. So we're going to check for new posts only once a day. And then for the comments, we might say, well, this needs to be happening a bit more often, because people might be commenting more often than that we're posting. And I'm going to say, here we have our next options, revalidate, and I'm going to just say 60. So whenever someone places a comment, at most we are going to wait 60 seconds until that comment shows up. We might even set it to like 10 seconds, even shorter. All right, so I'm going to say posts, which maybe I myself as a blog hoster or whatever make. We're just going to revalidate it every day. But comments might show up all the time. We might revalidate it for 10 seconds. So now, instead of caching the whole HTML, Next will now cache the result, the response of the fetch, the HTTP response. And it will still regenerate the HTML for each request, but at least the fetched data is already here. It's statically saved. So the generation of the HTML is much quicker. But now every 10 seconds we're just going to refetch the comments, because those might change much more often. So we can even have control over the individual fetch requests. Just going to comment this out because it will not work. So, but you get the idea. All right, so that is incremental static regeneration or generation. So we set up an expiration timer or a revalidation timer for the validity of the HTML or the fetch request. Dynamic rendering then. Let's say that I want this page, I want it to just always be re-rendered, right? Things are changing so often, the comments are changing so often, people might make posts all of the time. We're just going to have to regenerate this page every time. In order to do that, we can export, not default, export const dynamic, and I actually have to look it up in the docs because I always forget the options here. So NextJS docs dynamic rendering. And the docs are really good. So static and dynamic rendering. So, or we can just search for dynamic. That's dynamic routes. Maybe it's this one. Yeah, this is the one. So options, dynamic. So this is what we can export, dynamic. Auto, force dynamic. Not sure exactly what error does. You could read about it here, I guess. But we want to force dynamic. So dynamic is string force dynamic. So now everything on this page will always be re-rendered, regardless of any time it takes. So let's get our post. Oh, of course, we can't get the comments. So let's comment it out. All right, so we got Next.js. Let me change this to hello. Save, reload, it's generated, right? So every request, even if there's thousands of requests every minute, even every second for big applications, it will always be regenerated. So if you have data that always constantly changes, you might just do this. Same as with the revalidate timer, you can also do it per fetch, but now it's actually a separate cache option, and we can set it to force cache, to always cache it, or no cache. And there's a couple of other options. Again, I have to look it up in the documentation. But for example, no cache would always invalidate this request. So it would still always re-render this request. But we can now do it per fetch request. So if I change this back to Next.js, you can see that we get a request again. So we can either do it for the whole component page or per request, per fetch. All right, so this is how we have control over the server-side rendering type that we use. So without any options, static, the server will just save the HTML forever. If we're going to have dynamically changing data, we might want to adopt incremental static regeneration with a revalidate timer, or dynamic rendering by just forcing dynamic on the whole page, or we can do both of these per fetch request as well. It is a bit of stuff to wrap your mind around, right? It can take a bit of time. But once you start playing around a little bit, this will make sense quite quickly, I think. Now let's talk about client-side stuff. So when we talk about client-side stuff, we really mean that the component, let me just change this to, you know what, we'll just leave no cache here. So let's when we're talking about client-side rendering, we're meaning that a component is just not rendered on the server. The HTML is not created on the server and then sent to the browser. No, the component's JavaScript code is sent to the browser, like normal React without Next. And then browser side, client side, then we're going to run the component. In NextJS, you don't really need or want to use client-side components that often. There's only one reason to use client-side components, and that is you're going to have to do some kind of interaction with the user or with the browser. So let's say we need to store something in the local host storage of the browser. So localhost. I guess there's some kind of stuff from previous apps that I was making. Let's say we need to store something in localhost. Well, obviously I can't just write like local storage, sorry, not localhost, local storage dot set item test hello. This will not work. In fact, if I save this file, we're immediately going to get an error. Local storage is not defined. Why do we get this error? So Next is trying to run this component, this page, on the server, because that's the default. Remember, this is default. Server-side is default. Server-side static generation is default, right? So it's not running this on the client. So this function, right, this post-page component is running on the server. The server has no clue what local storage is. It's a browser API. It's something that the browser allows us to work with. Server has no local storage. If we're wanting to do something with events, so let me add a button. Click me. And we have an on-click event. Oops, on-click event listener. That would trigger a browser function alert to show a little pop-up. This will not work. Event handlers cannot be passed to client component props. Errors. It's trying to set up this event listener on the server, and I guess it just can't do it. I'm not sure exactly why, but it can't do it. Because, of course, this is something that needs to happen client-side. Setting up an event listener is a client-side thing. It's something that the browser needs to do. The browser needs to listen for the on-click. We can't do this on the server. So this cannot work. Same as with React client-side stuff, like use effect. Use effect. Like this. It's not going to work. You're importing a component that needs use effect. Only works in a client component. If I need to set up state. Use state is just a way that the browser will manage variables for you. Doesn't work in the server. Right, nothing that you're familiar with in React or that you would normally do with JavaScript in the browser works. Which is kind of sad. The only thing that your server can do is fetch data, render HTML. And run your own server-side things like interacting with a database or whatever you need to do. But that's the only thing that your server will do. So the choice to make, or the thought process of choosing whether your component needs to be server-side or client-side is quite simple. If you have to do anything that can only be done client-side, then you use client-side component. Otherwise, server-side component. It's quite easy. So, how do we make a client-side component? I'm going to make a little example here for you. Let's say that in our root layout, I want to have a nav bar on top of all of the pages. Doesn't matter which page we're on, I want a nav bar. So I might create a nav element here. And we might create links. And I have already said that the A tags are not the right way to do links. We'll come to that later. And let's say we want to go home. We want to go to our about page. And we want to go to the posts page. Let's quickly set up an href here to go to slash. /about and /post. So this navbar is now on top of all of the children. So it doesn't really work with our post layout, but you get the idea, right? It's in the root layout. Anything that's rendered will get this navbar. Now, something that you very often put in a navbar is maybe a search bar. So maybe we want a search bar in this nav section for searching for posts. So we make an input element here, and we will set the type to be search, and a placeholder search posts. So now we get a little search bar here. Now, this is part of a form, really. Let's actually put it into a form to make it a bit more semantically correct. So the way that you would normally react with forms in in React is you would set up state. You see why we're getting a problem here. So we set up state. So this is the search, and set search is use state. The state will store an empty string by default. Then the value we want to show in the search bar is the actual search value. And on change, we're going to change the set search to be the event. And this is just normal React stuff to handle forms, e.target.value. Alright, so this is how we would normally handle a form and input. We store each value in state, and then we have complete control over the input. Not going to work. Use state only works in a client component. Now the way that we make a client component is by putting a string use client on top of your component. Now right now it will work. But it also means that our whole layout is a client component. And that might not be the ideal thing, because these links don't need to be rendered client-side. The children, we don't want them to be rendered client-side. Now everything suddenly becomes client-side. Only this form needs to be client-side. So the way that you would ideally do this is you would extract the client-side component from your server component. So in this case, only the form and the use state needs to be extracted. Let's go into the source folder. I'm going to make a components folder. And let's call this the search bar component. And this is just a good practice anyway, right? We have multiple things happening. We have the page, we have the nav bar, and we have a search bar. It's a good idea to kind of separate things. Separation of concerns. Export default function search bar. And we return. Let's cut the form out. We return the form. And we're just going to grab the state. So now we don't need to import use state here. So we set up our state, and now we just need to import use state. And now we have separated just the form, search bar forms behavior into a separate component. This we can now add as a normal component within this. And this single component we're going to use client side, use client. So what's going to happen is that this layout is still the default server-side rendered. And because we're not dealing with revalidation or incremental, whatever, or caching, it is actually a statically generated server-side component. But we are inserting a search bar component that is client-side. So basically what React or what Next will do is it will statically render everything here except the search bar. And then once the actual HTML goes client-side, then we're going to hydrate that search bar. So hydration is simply that small part is still reserved to do client-side. So this search bar will only be rendered when we are on the client. So all of the HTML other than the search bar will be rendered server-side and saved statically. But then once that HTML is in the client-side, the client-side search bar component is sent as JavaScript, and that will then add the search bar. And now we can do all of this here. And if I check my components here, let's see if we can find my search bar somewhere. I don't know. There it is, search bar. We now should have, if it wants to load, a timeout occurred. Interesting, I'm not sure why this is not working. Oh, maybe the dev tools don't work anymore, I don't know. But this should be now client-side. So I can actually show you this by maybe putting like a paragraph with the search value. just to show you that whatever I change in here, we are using state to react and updating this paragraph. But that, of course, is all happening client-side. So whenever you're doing something that needs to have client-side capabilities, like maybe we need the button in here that says search. So we have our search button, and we might have an onSubmit form event handler here. And we might do like an e.prevent default, and then maybe an alert with that search term. This is an event handler. So we'll say hello, click, and now we're getting that alert message. This alert message is something that the browser can do, right? It can't be done server-side. It cannot be done client-side. So use client, you just put on top of a component in which you do client-side things. Event handlers, forms, state, use effect, use context, stuff like that. So that is how we can separate the client-side and the server-side behavior. And the same thing is happening here. If you have a server component with a revalidation timer, but we also have a client-side component within it, that server component will just be doing its own incremental static generation, and then the client-side component will just be sent client-side. And if we have a client-side component like without any server-side stuff happening on it, like we have a use effect and then fetching stuff there, then everything is just happening client-side. So we have this use client string to separate components that we need to render client-side from server-side. Server-side is the default, client-side is optional. And you only really want to do client-side stuff if you really have to, because you're using browser things. That's it. So with that, we have now learned not only to do the routing, but also the different ways to render the components. If you know this, and you have to play around with it to really wrap your head around it, does take a bit of time. But if you know all of the stuff that we have talked about, you know literally 90% of Next. All of the others is just extras on top of this. Now there's two more things I would like to talk about. One is metadata. So what do I mean about metadata? Metadata is stuff that normally you would put in your head element. And we don't actually have a head element. So we only have a body. Right, so we have this body element, but no head. But there is actually a head element added to the page. Next will create a head element with, I guess, scripts and CSS and some default things like the UTF-8 character set and the viewport that you would normally do. But this is all stuff that Next just does automatically. But what if I want to change the title or add a description or keywords? Well, there's two ways we can do that. So let's go to the root layout and we can export another value called metadata. And this is going to be an object. And in this object we have to put in the fields of metadata we want to add to the page. Now what will be really helpful if you're using TypeScript is actually to use the metadata type from Next. Because now we get IntelliSense to see what we can put in here. So like a title. And the title needs to be a string or a template string or null or undefined. So let's call this the NextJS crash course. And because we apply this metadata to the root layout, this title, look in the top left, is now applied to all of my pages. All of my pages get this metadata. Search engines, Google, will see this title. So this is good for search engine optimization. Now, if I want to have a different title for maybe my posts page, I can simply export const metadata. And we set up a different title, all posts. So my homepage just has NextJS crash course, but my post page has all posts. So we have overwritten the metadata from the root layout. Let's say I go to an actual post, post/1. We still have the NextJS crash course because that is the default one from the root layout. Let's say in my dynamic route over here, I want to actually have metadata with the title of the post. Now, if I'm going to export const metadata, how are we going to get the title of the post? This post doesn't exist in this scope. It only exists in the component, and only after we have fetched that post. So instead of exporting a const metadata object, we can actually export an async function called generate metadata. And the idea is that within this function, the idea is that within this function you will be returning a metadata object. But we now have an async function where we can, for example, fetch that post with the parems. Now the parems are not known here, so we can actually, Next will also pass that same parems property to the generate metadata. Alright, so we get our parems also given to the generate metadata where we fetch the post, and then we can just simply return title, which is post.title. So this function will now run on the server to generate the metadata. And now we should have our post page, or post title. And we are not, so it's not actually applying it because we're not revalidating this page. So export const re, actually let's do dynamic, and is, what was it, no dynamic? I always forget what it is. Nope, I forgot. Force dynamic, not no dynamic, force. Oh, and I named the function wrong, metadata, there we go. Yeah, there we go, first post, or we could go to our NextJS post, there we have NextJS. So now we are generating the metadata dynamically on the server. Now you may have already noticed that there might be a small problem with this. So we run the generate metadata function and we run the actual page function, and both are fetching exactly the same data. Now, because we are forcing this to be dynamic, we are not actually caching the fetch result, or are we? So when we are rendering any page for any request for any page, and Next discovers that you're fetching exactly the same request during the rendering of the single page, Next will just skip the other request. It will actually cache the request while we're still rendering the page. So it might first run generate metadata, fetch the post with that ID of 1 or whatever the ID is. And then when it's rendering the page, it needs the same fetch, but it matches the URL and it sees, oh, we already have that data. It caches it temporarily. So that post here is exactly the same data as the post here. It's not fetched again. This is called deduping or deduplicating requests. Whenever you have, even if I would do something stupid like this, I'm making the requests 5 times. Only the first request will actually be made. Even though we have the code to make another fetch request, the request is already cached. So then we can just continue. Right, so however many times you're requesting the same thing, don't worry about it. Right, so this makes it a lot easier. You can kind of be a little bit lazy with this. You don't have to optimize your request like that. We don't have to have a separate function that caches the request to use over here and here. Next already does it for you. So another really cool feature about optimizing requests. So we either export a static metadata object or we generate it dynamically. So that's how we work with metadata. And by the way, in the metadata, you can also put things like, you know, your description. This is a Next.js course. You might have your keywords, which can be either a single string or an array of keywords. So Next.js, crash, course, dev history, I don't know. So now this is in my root layout. So now all of my pages will have in the head, they will have a description. This is a Next.js course. There's the keywords, comma separated. You can overwrite the viewport, whatever you need there. So that's pretty cool stuff. And that's how we would dynamically or statically generate or select the metadata for each individual page. Cool. All right, so one final optimization I want to talk about before we're going to talk about the final subject, which is API routes, is in the routing. So right now, when I've made links like this home page, the about page, the post page, these links here, these are very unoptimized links. So watch this. I'm going to go to the home page. Let's just clear the network tab and I'm going to load this page. right? So we're getting a few requests made. So there's the localhost HTML. Again, this is the HTML that the server has generated, right? This is the statically cached HTML that's saved on the server. That's what we have here. Here we have that CSS file that's been generated based on Tailwind. Then there's some JavaScript code that we need for Webpack and hot module replacement to automatically reload the page whenever I make a change in the code. But this is the stuff that we're fetching, right? And it's, let's see, it is, you can kind of see it is 6.5 megabytes, right? So it's quite a large amount of data. It's not too small. So this is what we need for our app. But if I navigate to the About page, we're getting the HTML for the About page, but we're also getting the same CSS file, the same Webpack code, the same build JavaScript code, which is exactly the same as what we had in our home page. If I go to the post page, we get our generated post page from the server, but we're also getting the same CSS again. So this is not ideal. When you're using the A tag, for example, in the navbar where we use it, that is of course the default browser A tag. And what the browser simply does is it requests, it makes a new request for this page. So it just requests everything that this page needs. And of course that is not optimized. Next gives us a much optimized way to do this. We can use the link component. So we import that from from next/link. And the props for this component are exactly the same as the A tag. So we have an href. So you can literally just replace all of your A tags with a link. By the way, you only want to do this for internal navigation. If you navigate to an external website, just use an A tag. But this is for internal navigation. Let's also do that on the post list over here. So we import link. And there we go. So now let's go back to the home page. Let me just reload. So we clear the network tab, reload. So that first reload, obviously we're getting all of the code that we're going to need. There's the HTML, there is our CSS, the Webpack. But now I'm going to click to About. And look at that. There's only one extra request made, which contains, actually I'm not 100% sure what this is. It's some kind of data object containing the data that React needs to client-side swap that children page property around. So the navbar is unaltered. It's still here. It's only got the data that React client-side will need to swap around the content on the page. It actually doesn't load a new page. It's only swapping the components around. Same if I go to posts. So now we get this post page. There's something in here, I don't know. And then we get some JavaScript that apparently we need for this page. But we are not getting all of the other things that we already had. Those are still here. If I click on first post, we only get the data for that first post. Again, I'm not entirely certain how that data is encoded or whatever. I'm not sure, but you get the idea. So this link is going to massively optimize the navigation of your pages. It makes it almost instant, really. Really, really nice. It's extremely fast loading. So it literally takes like a couple of milliseconds instead of hundreds of milliseconds to load your app. And it saves a lot of data transfer. If you're on like a limited mobile network where you have limited gigabytes of data transfer, this is massively optimizing that, massively. Because this request here was only 775 bytes, 398 bytes instead of the 6 megabytes we had to get for just getting all of the app's code. So it's massively optimized. Right, so always use your link component for internal navigation. Now finally, the last thing I want to talk about are API routes. So because Next is also a server framework, we can also just set up HTTP API endpoints. So we can just make a request, like a GET request for some data. Now, right now we're using this kind of automated JSON database, but let's imagine that we don't have that. And we have our own database where we need to use some kind of database client, like an SQL client where we have our SQL code to interact with the database. So maybe I want to just get something out of our database. Now, we don't want to, of course, set up a page that maybe fetches that data and renders it. Maybe that's something we want to do, But sometimes you just want to make an HTTP endpoint that just sends the JSON data from your database. So let's do that. Now the way that we do that is in our app we can make our layout and our page files. There's loads of other files as well. You can check the documentation for the not found file or the error file or all kinds of other stuff that it will render components for. But there's also a file called route. And when you set up a route, you can then that will then define API endpoints at the URL created by your folder structure. So what I usually do is create a folder called API right at the root of the app. And that will then be your kind of sub route. So /API / something else. I usually put all of my API stuff under this kind of shared API folder. And let's say I want kind of a user. So I want to get /API / user to maybe download or get some user data from maybe whoever's logged in. Let's say we have some kind of authentication system and we need to fetch the data for the signed in user. So in here I'm going to make a route.ts file. Doesn't need to be TSX, we're not rendering a React component. And what we're going to need to do here is export, not as a default export, but just a single async function. And this needs to be named, this function's name is important, it needs to be named after an HTTP method that you would like to catch the request for at this route. So /API / user, if we make a GET request, this function will catch that. Now, we can actually get the request object out of the request type. So, for example, if I were to console.log request dot maybe method, or I think we can also get, headers. So for example, headers, we could do something like that. So this now captures a GET request to /API / user. And right now in the server's console, we're just going to log the headers, just as a little example. So let's make a GET request. In the browser, the address bar will always make a GET request to API / user. Now the browser is awaiting something to be received. We're not getting anything, of course. But as you can see, we are logging all of the crazy headers that the browser is sending. So you can just get the data out of the request. Or with a post request, you can read the body or something like that. But let's say we have some data like my user. We can, of course, imagine this comes from a database. I'm just hard coding it here. So we have a name, John. We might have an email, jdo@gmail.com. I don't know, this is maybe the data of the user's account. And then we need to return a new next response. Actually, I don't think it's a new next response, just return a next response .json in our case. So we can parse that user object to JSON. Right, so this will now return and send a response when we got this request. So we don't have to get the request if we're not using it. And this is how we set up an endpoint for a GET request to this route. /API / user, we have a GET function to handle the GET request. We can also do something like a POST request, but then you would name this POST. And then you would read the request body and then send a response with whatever the POST has done. So let's try this out. So let's re-request /API / user, and now we're getting that JSON object. So instead of rendering pages, we're just sending data. Or we're handling posts to send something to the server, or patch or put to update, or delete to delete something from the database or whatever. There's loads of other things you can do with this. Again, all of the things I'm handling in this crash course are the basics of these subjects. I highly recommend you check out the documentation if you're going to work with these things, because there's loads of other things you might have to think about. But that's the basics of API endpoints. You don't have to use the API folder. I can also just create an route.ts at the root, but then this will always match the URL / of course, so now no pages will be rendered. But you can put routes in any URL. But I like to just group them under API. Alright, so with that, I think we have reached the end of this crash course. There's loads of other things that Next will do for you, and that you might have to configure or might want to play around with, but that is the basics. So I hope you enjoyed this video. Let me know what you thought about it in the comments. Also, press that like button if you did like it. And if you want to see the next few videos, subscribe to the channel, because I will be making a small series of videos all about kind of professional level app development, web app development with Next.js, and loads of other things. We're going to implement authentication for user accounts, databases, good coding practices, reusable UI components, all kinds of stuff. So make sure you subscribe so you get those other videos. And other than that, thank you so much for watching, and I'll see you in the next video.